All right, here we go with another integral, and this is a trig integral. It's the integral of cotangent e to the negative x over e to the x. So for this one, well, the only thing we really have going for us is we know that we can integrate a trig function, any trig function now that we've learned natural log. So any trig function, sine, cosine, tangent, secant, etc., of u, du, we have formulas for. So we'd like this to be cotangent of u. Now, before we do, let's just think if that makes sense. If u is e to the negative x, then du is negative e to the negative x. And e to the negative x is 1 over e to the positive x. If you notice, we have a dx over e to the positive x. That's looking good. So I'm going to go along with my u substitution of u equals e to the negative x. So du, the derivative of e to the negative x, would be e to the negative x times the derivative of negative x, which is negative 1 dx. And if you rewrite that, you will have negative 1 over e to the x, because that's a property of exponents. Negative exponents change their signs. And that's it. So if you notice on the original integral, we have dx over e to the x. On our du, we have dx over e to the x. That equals negative du. So this integral can be rewritten as cotangent of u, and then dx over e to the x we said was a negative du. So now all you have to do is remember what the integral of cotangent of u is. So either you have that memorized, or you remember cotangent is cosine over sine, and cosine is the exact derivative of sine. Therefore, this is u prime over u. So it would be the natural log of the bottom or the natural log of sine. So that's how you figure out what the integral of cotangent is. It's the natural log of sine. So we have this negative. The integral is the natural log of the absolute value of sine of u. I'm going to plug in my u right away. So u was e to the negative x, or 1 over e to the x, plus c. And we are finished. Wolfram Alpha, the big reveal, looks nothing like it. So you have to be very careful here. We don't want to spend a lot of time trying to figure out if, like, what we did wrong here, because I think we did everything right. So be careful when you're checking on Wolfram Alpha or any other kind of software you check with. But let's look at this answer and make sure it agrees. So Wolfram Alpha says it's the negative natural log of tangent minus the natural log of cosine. So I'm going to just try to make sure that that agrees with our answer. It's probably properties of logs. So the first thing I'm going to do is factor out a negative here on Wolfram Alpha's answer and change these logs to ln's as we're more familiar with. So tangent e to the negative x plus natural log of cosine of e to the negative x. The addition property of the logs allows you to make this the natural log of tangent e to the negative x times cosine e to the negative x. So negative natural log of, now tangent is sine over cosine. So this is looking really good right now. because you can see that you can cancel out these cosines. I lost one of my parentheses, I don't know why. And we have negative natural log of the absolute value of sine e to the negative x plus c, which is what we got. So looks like Wolfram Alpha's simplification was a little bit lacking, I would say, because ours is much more simplified. So that's just whatever software they use to do it, uh, just does it that way. So there you go. Thank you for watching as always, and I will see you next time.